Okay, so here we go with example number 2. So we're starting, this is referred to as graphing form, but we're going to go ahead and make this have a common denominator so that we can do the rest of the problem. So I went through and I multiplied this 2 by x plus 1 over x plus 1, and that led me to this. Then I went through and I found my key features. So to start off, we have a vertical asymptote at x equals -1. So I'm going to draw that in. So there's my vertical asymptote. Now I need my horizontal asymptote, which is at y equals 2. So here's 1, 2, and now I need a horizontal asymptote. Okay. So there are my asymptotes. Next up, I have a y-intercept at 0, 5. There were no holes on this one, so just my y-intercept at 0, 5. So that's up here. And then I have an x-intercept at -5/2, or -2.5, 0. So -2.5, there is my x-intercept. And now from here, we are not allowed to cross the horizontal asymptote. If I set that function equal to 2 and try to solve, I will not get a solution. So I cannot cross the HA. So this one I'm not actually going to need any confirmation points because I have 1 point on either side and I know I cannot cross the HA. So drawing these branches should be a little bit easier than they were in problem number 1. All right, so off on the right-hand side, I have a point above, so I need to stay above at all times, but I need to approach that vertical asymptote. So I'm actually going to extend this up a little bit higher, and I'm going to show that I'm near it on that side, go through my y-intercept, and then approach the horizontal asymptote without crossing through it. And then I'm going to do something very similar on the left-hand side, but I have to go through this point, which is below the HA. And since I'm below the HA and I cannot cross through the HA, I need to stay below it at all times. So I'm going to start off below it, but near it. Go through my x-intercept and down. Okay? And there's my graph of that rational function. And again, if you're not sure where the branches belong, you're always welcome to plug in extra x values to the original function to see if you get points that match up with what you were thinking. Okay? So when in doubt, plug in chug and get some extra corner points. But that's how I graph problem number 2.